In this video, we are going to discuss about the ARM processor modes. So let's recall the last class topic. In last class, we have discussed about the ARM processor memory organization. In that, we are focused on important areas and architecture overview, memory maps of ARM processor, and endians, that is byte ordering and little endian and big endian modes, memory alignment and assembly language instructions, that is load and store instructions. And today's topics for discussion we'll begin with the ARM processor modes overview, the current program status register CPSR, and the different types of modes, that is the user mode, the default playground, and the SVC mode, the OS gateway, and IRQ mode, handling hardware events. Now let's begin with the today's ARM processor modes overview. So the ARM processor modes understanding system control. So it gives the we know that. So why are processor modes so important? They create differential execution and environments. This separation is the bedrock of system security and stability, ensuring that the user application cannot accidentally crash the entire system. This is absolutely essential for any operating systems to function systematically. And now let's move on to the brainstorming with why modes matter and your phone's OS. So now let's make this real with a familiar example. Here, your smartphone. Have you ever noticed that when the game or app crashes, your entire phone doesn't freeze? This processor mode's in action. So apps run in restricted user mode, which limits their access to sensitive hardware. The operating system kernel running in privileged modes, so acts as a protector, isolating app failures and safeguarding critical resources to prevent total system failure. So now let's move on to the ARM processor modes overview. So ARM processors are broadly split into three different types. So ARM modes are broadly split into two categories. The first is a privileged mode, so which have full access to all system resources, and the second one is the non-privileged mode known as user mode in the ARM 7A profile. So there are 7 core modes, that is user, FIQ, IRQ, supervisor, abort, undefined and system modes. So now let's see the CPSR, that is the current program status register. We know that the key to controlling and identifying the current mode is the CPSR, that is the current program status register. So this is special register holds the processor's state. In critical fields, it includes the mode bits, that is which select the active processor mode, the first and F bits for disabling interrupts, and the T bit which indicates whether the processor is executing standard ARM or compact thumb instructions. So now let's move on to the user mode, that is the default playground. This brings us to user mode. This is the default and non-privileged playground where all your applications run, your web browser, your games, and etc. It is the most restricted mode. Code running here cannot directly access hardware peripherals or modify protected memory regions. This restriction is what ensures that a buggy app doesn't bring down your whole system. Now let's move on to the SVC mode, that is the OS gateway. So when the application needs to perform a privileged actions like writing a file, it must request help from the operating system. This is done through system call, which triggers a switch to supervisor mode or SVC. This is privileged mode acting as the OS gateway. It handles critical operations like memory allocation and file input output, providing a controlled and secure transition from the restricted user mode. The next one is the IRQ mode, handling hardware events. For responding to external events, we have the IRQ mode. This is another privileged mode. And dedicated to handling general purpose interrupt requests from hardware devices like a keyboard press or a timer tick. When an interrupt occurs, the processor switches to IRQ mode to run the kernel's interrupt service runtime, ensuring a timely and organized response to hardware events. And the last one is the ideate or OS kernel role play. So let's see how these modes work together. Imagine an app in a user mode wants to serve a file and it makes a request. Then the OS kernel switches to SVC mode. In this privileged mode, it performs the actual disk write, and finally it returns the control to user mode, and the app container was completely unaware of the privileged operations that just occurred on its behalf. And the next one is the prototype entering IQR mode concept. How do we enter these modes for an interrupt? The processor is automatic, and a hardware trigger causes the processor to save the current CPSR, switch to IRQ mode, and jump to a specific memory addresses to run the interrupt handler. Programmatically, a mode change can be done within instructions like MSR-CPSRC, and value of 0xD2 corresponds to the configuration of IRQ mode. Now let's move on to the test and conclusion part. So the MCQ, which mode handles general hardware interrupts, that is user, IRQ and SVC. Answer is SVC. The ARM processor modes form the foundation of secure and stable systems. Differentiated access levels ensure robust operation, and this will give the critical for modern operating system design and functionality. These are all the references for this topic, and the mind map of this topic is the ARM processor modes, purpose and importance, modes of categories, ARM7 core modes and key mode details, and the prototyping one. And these are all the references. Thank you.